All right, let's get right into it, because today we are unpacking a potential bombshell from Tesla that could completely flip the world of AI on its head. It's a plan so massive, it's actually kind of hard to wrap your head around at first.
And look, the first thing you need to grasp is just the insane scale of this claim. According to the source material, we're not talking about some small update here. The thinking is that this could be a bigger deal than some of the top names in AI today.
So here it is, the core claim, a plan to build an AI compute network that is 5 times, not 50%, but 5 times bigger than every major data center on the planet put together. I mean, that's a staggering leap in raw power.
But how? How could you possibly do that? Well, get this. The craziest part is that the foundation for this whole thing is supposedly already built and scattered all around us. So, what is this secret plan? Well, the secret is hiding in plain sight. We're talking about Tesla's Supercharger network. You've probably driven right past these things 100 times. This global network is apparently the backbone for what the source is calling the Macrohard Plan.
And to really get the scale, you have to start with this number. There are over 70,000 of these supercharger stalls all over the world. That's more than 70,000 little outposts, already built, already powered, just sitting there.
And here is the big aha moment. These aren't just plugs for your car. Each one is a pre-installed tap into a massive electrical grid. They've already solved the hardest, most expensive part of building a data center, getting access to huge amounts of power.
And that's what's so elegant about this idea. It's shockingly simple. Step 1, you show up with a pre-built fridge-sized cabinet full of AI chips. Step 2, you just plug it into the power that's already there. And boom, Step 3, you've just turned on a new node in a single planet-wide supercomputer.
Okay, so we've heard this phrase 5 times more compute. But what does that actually look like? It's a number that's so big, it's kind of hard to visualize, so let's try to put it in perspective.
All right, here's the magic number that was reportedly mentioned. 7 gigawatts. That's the total amount of power that could be dedicated to AI across this network. You know, a single gigawatt can power a pretty big city. So we're talking about an incredible amount of raw energy just waiting to be used.
Now look at this. You take every single major AI data center that exists today, from Google, from Amazon, all of them, and you're looking at a combined power draw of about 1.2 gigawatts. This supercharger plan? 7 gigawatts. It's not even in the same league. It completely dwarfs everything that exists today.
And you know what's really wild is that this new plan makes their old big plan look tiny. Remember the idea of using all the computers inside Tesla cars? That was already a huge idea, about 800 megawatts. This new plan is almost 10 times bigger. It's on a whole other level.
So how does this all work without building one giant centralized building? Well, it's a concept called distributed inference. Think of it like this. Instead of building one massive kitchen to cook a giant meal, which takes forever to get permits for, you give a small part of the recipe to thousands of little kitchens all over the country that are already built. You get to skip all the bottlenecks.
So, we've talked about the what. Now let's get into the why. Because this isn't just some cool engineering project. It's a brilliant business strategy, one that our source directly compares to another one of Elon Musk's companies.
So none of this is even possible without the secret sauce, and that is Tesla's own custom silicon. The claim is their next-gen AI 5 chip will have performance in the same class as NVIDIA's best, but using a quarter of the power and, this is the really important part, at a tenth of the cost.
So what does that cost advantage actually mean in dollars? Well, this is where it gets really crazy. To build a traditional 1 gigawatt data center today, you're looking at about $35 billion. With Tesla's approach, using cheaper chips and power infrastructure that's already paid for, the estimate is they could do it for around $7 billion. That's 5 times cheaper. And this kicks off what you call a flywheel. It just feeds itself. You design cheaper, more efficient chips. You then become your own biggest customer, deploying them on your global network. You use all that power for your own products, like the Optimus robot. And then, with all that leftover capacity, you can rent it out to everybody else, kind of like your own AWS for AI.
And if this strategy sounds familiar, it should. This is the exact same playbook SpaceX used with rockets. They made launching cheaper, used those cheap launches for their own massive project, Starlink, and that scale allowed them to completely dominate the entire launch industry. It's the same move, just for AI.
Okay, but let's be real. A plan this huge, this audacious, it's not going to be easy, right? Of course not. So let's talk about the hurdles, and then the real end game.
You've got some serious engineering problems to solve. I mean, how do you keep these computer X cool in the middle of a desert and also in the Arctic?
How do you make sure every single one has a super fast internet connection? And the sheer logistics of doing this everywhere. But the perspective seems to be that these aren't deal breakers. They're just really hard problems that need to get solved. It's a case of engineering must occur.
Because those 7 gigawatts, well, that's just phase 1. The true long-term vision here is almost unbelievable. We're talking about eventually building out 500 gigawatts of dedicated solar and battery power completely off-grid just for AI and charging. The scale is just mind-bending.
Which brings us to the final, really big question. The whole point of a project this massive is to make AI compute so cheap and so abundant that it's like a utility. You just plug into it, like electricity. So if they pull that off, if AI becomes as common as flipping on a light switch, what does our world look like then? What happens next?